Good morning, good evening, good afternoon, good whatever time of day it is and whatever part of the world you're at right now. Welcome back. And today we're going to do another algebra lesson about the quadratic equation. And more specifically, we're going to talk about the vertex form of a quadratic equation. So first of all, we need to start with what is the vertex form of the quadratic equation. It is y equals a times the group of x minus h squared plus k, where h comma k is the vertex and h equals x serves as the axis of symmetry. So h and k are going to be numbers that we're going to identify in any quadratic equation that's written in vertex form, and we're going to identify them as the coordinates of the vertex, okay? So h is going to represent the x coordinate, and k is going to represent the y coordinate. Now, before we actually take a look at equations and try to identify the vertex and the axis of symmetry, I think it'll be good if we actually take time to write equations in vertex form, quadratic equations in vertex form, given the vertex, okay? And we're going to just assume that all of these equations that we're writing, that a equals 1, all right? So what I want to do first is rewrite the vertex form, okay? And we've already discussed that h and k are coordinates of the vertex, okay? So if I wanted to write the equation here, I could just plug these values in, and this would be y equals, we already said that a would be 1, so that's x minus, now we have to put the negative 3 here, and then squared plus 2. The 2 is positive, so we leave it as plus 2. Now when we simplify everything, this would be y equals x plus 3 squared plus 2. Even though the x coordinate was negative, when we write it, it's kind of deceiving, and it looks as though that the x coordinate is a positive 3. But really, for the vertex, it was negative 3. Let's take a look at this next equation. So we'll take time to rewrite it again. Y equals a times x minus h squared plus k. And remember, we're going to say that the 4 is h and negative 9 is k. So when we rewrite it, this would be y equals, and we already said that a is going to be 1 for all of these. So that's x minus 4 squared plus, and then this is going to be negative 9, but when we simplify everything, this is going to just become x minus 4 squared minus 9, okay? So when k is positive, you write it as positive, and when it's negative, you write it as negative. But when h is positive, when you write it in the vertex formula, it reads as a negative 4, but really it's supposed to be positive 4. What about if one of the coordinates is 0 for the vertex? So let's take a look at that. This is h, that's k. Let's write out the vertex form. That's a times the group of x minus h squared plus k, and we're going to rewrite it. So that's y equals x minus 0 squared minus 2, but x minus 0 is just x, so this is really just going to be y equals x squared minus 2. Okay, so when when h is 0, it's going to just look like x squared, y equals x squared minus or plus a number. Now, in the last one, y equals a times x minus h squared plus k. We know that h is negative 5 and k is 0, so what does it look like when k is 0? Y equals x minus negative 5 squared plus 0, which is really just y equals x plus 5 squared. And that's it, because plus 0, we don't need to write it. So when the k is 0, it's just going to be x plus or minus a number squared, okay? Y equals the group of x plus or minus a number squared. So now that we have a better understanding of that, let's go ahead and look at these equations and identify our vertex and our axis of symmetry. So here's h and here's k. Now, this says x plus 4, but we know that h is really a negative 4. Now, k is actually what it is. It's in a negative 2. So when we write our vertex, it's going to write it as negative 4, comma, negative 2. And our axis of symmetry is x equals h. Well, h is negative 2, so this is going to be, h is negative 4. So we would write it as x equals negative 4. Let's take a look at number 2. Number 2, here's h and k, but really there's no number on the outside. There's no plus or minus a number on the outside, so k is really 0. However, h is h is not negative 3, but positive 3, because it's written as x minus a number, so that number is really positive. So that's h equals 3, and k is equal to 0. So when we write our vertex, it's going to be 0, comma 3, and when we write our axis of symmetry, is x is equal to h, which h is 3. So when we write our vertex is really 3, comma 0, and our axis of symmetry is x equals 3. Now for number 3, let's identify our h and k. All right. So in this one, h is actually positive 5, and k is actually negative 4. So when we write our vertex, it's positive 5, comma negative 4, and the axis of symmetry is x equals positive 5. And let's take a look at our last one. Number 4. Number 4, h is over here, and then this is k. Now for our h, we don't have a number, so which means that h is actually 0, and k is positive 3. So our vertex here is 0, comma, positive 3, and our axis of symmetry is x equals 0. Okay? And that's how you identify the vertex and the axis of symmetry when the equation is written in vertex form.